Good morning, everybody, or afternoon, or whenever it is you're watching this video. I hope you guys are doing well and had a good weekend. It is Monday. We are on to our next lesson today. As of today, so this is the 20th of April. As of today, we only have 1 month left of school. So the very last day of school is May 20th. So we've got 1 month from today is the last day of school, which is, kind of exciting. And then you guys are moving on to high school after that. So a couple things I want to go through before we get to our lesson. The first thing is Canvas. There was some confusion recently about Canvas, about being able to find daily assignments. Just so you guys know, I always post, so like if this is your home screen, or so here's home, right? And by the way, if you're wondering why there's purple around here, this is just how it looks when I go to the student view. It kind of shows like a little purple ring around it. Yours obviously doesn't have a purple ring, but this is your home screen. What you're going to do is you're going to click on so actually a lot of times the assignments will be posted here in the to-do section on the right. Okay, so usually you'll be able to find there. If you can't, go to assignments. Okay, and usually I post like all your weekly assignments will be right here at the top, so you can see, week 1's was here, week 2's is above that, week 3, week 4 was last week, and then week 5 is today. So some of you are having issues finding one of the days last week. I don't know, maybe it wasn't showing up in your week 4 e-learning assignments last week. I don't know. But if you don't see it here, so if you don't see it on the home page, and if you don't see it in the assignments tab, click on quizzes right here, and there's a good chance it might show up in quizzes. So like down here, you can see 2 of the assignments we did last week fall underneath the quizzes category. They're actually surveys that I made, but if you click on quizzes, you might see it there. So if you don't see it on the home page, if you don't see it on the assignments page, if you don't see it, then you should hopefully be able to see it on the quizzes page. If you don't see it on one of those 3, then email me and ask me, because there might be some sort of an error. But you will get something every single day, Monday, Wednesday, and Friday. There won't ever be a day where I post nothing. Okay, so if you don't see something, make sure you double check with me, because there's probably some sort of an error. Okay. All right, so today our objective is to identify cross sections of 3-dimensional figures. Okay, so identifying cross section. An intersection is a point or a set of points common to 2 or more geometric figures. So if you think of an intersection, it's where 2 things cross, right? A plane is a flat surface that has no thickness and that extends forever. Okay, so we kind of have 2 vocab words here, intersection and plane so far. A cross section, then, is the intersection of a plane with a 3-dimensional figure. So like a plane basically is just a flat surface, and you can think it goes on forever in all directions. Just a flat, think of it like a piece of glass or a piece of paper that just goes on forever. Okay. A cross section then is if I have like a 3-dimensional shape. So let's say I have like this 3D shape here. It's like a little box. A cross section is if I were to take a piece of paper or a knife and slice it in some direction through this 3-dimensional shape. The cross section is the opening, the shape of the opening basically. So if I were to just take this and cut it right down the middle, like perpendicular at the top, the cross section would just be this rectangular shape right here. Okay. Okay, so imagine the ways in which a plane can slice through a cone or cylinder and the shapes that a slice can have. Okay, so this figure shows the intersection of a cone and a plane parallel to the cone's base. So this plane right here is the blue part. Okay, it's like a piece of paper that they're just slicing through the cone. Okay, the cross section then is this part right here that you can see this plane cuts through. It's like if you were to cut through that cone and then pull the cone apart, what shape would you see in that opening? Well, it'd be a circle, right? If you cut it in at that specific angle, it'd be a circle. Okay, this figure shows the intersection of a cylinder in a plane, but here it's not just going flat parallel with the ground, now it's going at an angle. Right? Now typically a cylinder is circular, right? It's got two circular bases. But when it goes up at an angle like this, now if we were to pull them apart, that opening isn't just going to be a regular cylinder, because now it's going to be cut at an angle. Now that opening is going to actually be an oval. Okay? So depending on which way this plane cuts through the shape, it might change what the shape of that opening is. Okay? All right, so what we want to do here is we want to describe each cross-section of the right rectangular prism with the name of its shape. In a right prism, all the sides connecting the bases are rectangles at right angles with the base. So why don't you see if you can figure out what these cross-sections are. So think to yourself, first let's start with A. Okay, so this is a right rectangular prism, mind you, not a right square prism, it's a right rectangular prism. Think to yourself, what is the shape of this cross-section right here? Okay, well look at this. It's just going, this cross-section is just going perpendicular straight up and down through this. Since it's a right rectangular prism, rectangular is the key word here, that means the cross-section then is going to be a rectangle. Okay. Now let's look at B. B, it's kind of going at an interesting angle, so it's going through, oh, I wish I had a Kleenex box here, but I don't. So it's going in at this back angle, this back corner right here, and then it's slicing through at an angle so that it's crossing at this corner and at this corner, and it kind of creates an interesting shape that you might not think of when it's crossing through a rectangular prism. What shape is created? Well, you can see here this shape is a triangle. You might not think that you would be able to create a triangle as a cross section with a prism like this, but if you go through these corners, you can. Okay, so this is a triangular cross section. Triangle. Okay. All right, C. Describe each cross-section of the right rectangular prism with the name of its shape. Okay, so for part C, we can see it's just crossing right here at this corner. What is the name of the cross-section here? Well, that's a triangle, right? That's a triangle. Part D, now it's going in kind of at an angle. Okay, again, this is a rectangular prism. Now it's not going straight up and down to form a rectangle, now it's going in at an angle. So what shape do you think this is? It's not a rectangle anymore because now it's kind of going at an angle. This is a parallelogram. Okay? All right. Now what do you think about this? It says, is it possible to have a circular cross-section in a right rectangular prism? So we've kind of talked about how you can have a triangle cross-section, you can have a rectangle cross-section, you can have a parallelogram cross-section. Do you think it's possible to have a circular cross-section when you go through a right rectangular prism? Well, the answer to that is probably no, right? Because if it were to be circular, that means that the sides would have to be round, but there aren't any round sides in a rectangular prism, right? Now you could have a circular cross-section in a cylinder, but probably not a right rectangular prism, right? All right, now describing cross-sections. A right rectangular pyramid is shown right here. It's got a non-square base. So if it's a non-square base, that means it's a rectangle, right? So the point where the triangular sides meet is centered over the base. So this, basically, it's just saying it's centered. It goes center over the base right here down to the center. Okay, so A, the shape of each side is a what? So these sides are all triangles, right? The shape of the base then, since it's a non-square base, the shape of the base has to be a rectangle. And then B, is it possible for a cross-section of the pyramid to have each shape? So let's look at this first one. Is it possible for there to be a cross-section that's a rectangle? Well, what do you think? Think to yourself, is it possible for us to have a rectangular cross section going through this pyramid? And the answer is yes. If we just go parallel to the base, we know the base is already a rectangle, right? So if we just cut through parallel to the base, we will get a rectangular cross section. So yes, it is possible. What about a square? Is it possible for us to get a square somehow? You might think yes, right? Okay, so like if we go parallel, are we going to get a square? No. We already know that if we go parallel to the base, we're going to get a rectangle. Okay, let's say we cut through like this. Is it possible then? Actually, no. We're going to find out here in just a second what that's going to look like. So actually, it's not possible to get a square here. What about a circle? Can we cut through this anyway to get a circle? Remember, a circle is going to look like that. I don't think so. No. Can we get a triangle in some way? The answer to that is yes, right? So like, let's say I were to take this and cut it, or go straight down so that it crosses right at the tip of this pyramid all the way to the base. What that's going to do is it's actually going to create a triangular cross section. So the answer to that is yes. And then this, a trapezoid, is actually a shape that looks like this. What do you think about that? Is it possible for us to make a cross section that becomes a trapezoid? The answer to that is actually yes. If I take a cross section and if I just cut it straight like this, right? So it's actually going to cut like this. This section, or this shape right here, is going to form, right? Think of the pyramids are going up like this. So some of you might think if I cut straight like this, it's going to form a square. But that's not the case, right? Because my sides are going up at an angle. So if I cut off part of it, it's going to form something that looks like this trapezoid right here. Okay, so the answer to this is yes. Okay. All right, C says sketch the cross sections of the right rectangular pyramid below. So if I look at this, here's a cross section of this pyramid. This is kind of an example of what we just talked about, right? This cross section is going to be it's called a trapezoid, right? What about this one right here, number 2? Okay, that cross section, remember this is a right rectangular pyramid, so this, since it's parallel with the base, it's just going to be a rectangle. And then this is what I was talking about with the triangle. It's going straight through the tip at the top, the vertex, straight parallel or perpendicular with the base. That's a triangular cross section right there. Ooh, that's a bad triangle. Forgive me for that one. All right, last thing. Describe each cross section. So what shape is shown by this cross section? Well, we can see this cross section right here. That's a rectangle. Okay, number 2. Here we have a cylinder, and we're cutting through at the basically perpendicular with the bases, right? What shape is this? Well, that's a rectangle too. Now you might think, how is that possible? How is it possible to have a rectangular cross section when we have a curved surface like this? Well, the cross section doesn't really look at the curved surface at all. Remember, it's just going through it. The cross section is the opening. The opening is just a rectangle. Okay, number 3. Here we have a cross section that we can see. We've got a pyramid, and the cross section is going up at an angle, right? So this forms a trapezoid. Okay, and then 4, we've got a cone here, and we've got our cross section going perpendicular with the base, but it's kind of going down on the side like that. In this case, this is a semicircle. A semicircle. Okay. All right. So that's all we have for today. Your assignment is actually on quizzes. You've been assigned a cross-sections quizzes. So what I want you to do is head over to quizzes.com, and you are going to complete the quizzes that I've assigned to you. Make sure you sign in with Google, okay, and complete that. And then that will be your assignment for today. If you have any questions, feel free to come and ask. Also, another thing I want to remind you of is today, starting today and every Monday, is the first hour Math Canvas Live question and answer session with me. So if you have a question today over anything that we've done, you can stop by here. I'll send an email, an invite out on Canvas to everybody around 1 o'clock p.m. So if you're around, you can come and ask questions if you have them. You don't have to come. It's completely optional. But if you do have questions, feel free to stop by and ask questions. I'm happy to help. You can stop by for 2 minutes if you want. You can stop by for the whole hour if you need help with the whole thing. But if you have any questions over anything, feel free to stop by or just come by and say hello. Okay. All right. Hopefully I'll see some of you today at 1. It'll last an hour. But if not, I hope you have a good day. Bye, guys.